In today's video, I have brought you a very nice problem of Indian Mathematical Olympiad, year 1991. Our goal, we are going to solve this following equation system in real numbers R. Okay, so here is the following equations. First equation, we have the sum of x plus y minus z equals 4. The second equation, we have x squared minus y squared plus z squared equals minus 4. And the last equation, we have the product xyz equals 6. So we have three parts of these equations. First part is a combination linear. The second part of this equation, we have quadratic form. The last one, we have the product of these variables. Okay. In fact, this equation looks like easy to solve, but isn't. It has a special trick. Okay, because if you try to use the first equation and you are going to multiply one of these variables by y x or y z or y x in order to get 6 replaced here, and then takes you to the next step where we can simplify the equation to the smallest expression possible, but it is not taking you to the solution. It takes you back to the where you were at. Okay, so there is a special trick of this one. So once you find the trick, everything else will be easier to solve. Now let's go through this one. I'm not going to use this equation. I'm going to use the Merrill equation. Okay, so we have x squared minus y squared plus z squared equals minus number 4. Okay, I'm going to leave this equation as it is, just moving this minus y squared to the right side. So I will get here x squared plus z squared equals y squared minus number 4. Okay, the left hand side of this equation is an completed square, so we are going to complete this square, or I can write it as x minus z square like this. If I'm going to distribute, this one is giving us x squared plus z squared minus 2xz. We don't have minus 2xz, we need to add that. Okay, we'll have 2xz, so equals y squared minus number 4 like this. Okay, now we are going to use the first equation. So I'm going to pick up the first equation and make the connection between this equation and the first equation. Okay, so I have x plus y minus z equals number 4. So which means I get x minus z equals 4 minus y. Okay, I'm simply going to replace x minus z with 4 minus y. I get here 4 minus y quantity squared plus 2xz equals y squared minus number 4. Okay, so we have, if you take a look carefully at this term, we have xz. So if I'm going to multiply both sides of this equation by y, I get the value of xyz here, because we have xyz equals 6. I'm simply going to multiply both sides of this equation by y. I get here y is multiplied by 4 minus y quantity square plus 2 times xyz equals y cubed minus 4y, because it was multiplied by y. Okay, so we know xyz equals 6 as we have in the given information. So I get here, I'm going to distribute this one. Y squared here as a first term is multiplied by y, which is y cubed, minus 2 times 4, which is minus 8y, is multiplied by this y, is giving us minus 8y squared. Then plus last term, which is 4 squared, which is 16. 16 is multiplied by y, is giving us plus 16y. This one, it's clearly 2 is multiplied by 6, which is 12. Plus 12 equals y cubed minus 4y. It seems we have a nice cancellation here at left and right side of this equation, so y squared will be cancelled out. I'm going to move over all the terms to one side, so I get here 8y squared I get here 16y, I get here minus 16y minus 4y, which is minus 20y, minus 12 equals 0. Okay, then I'm going to divide both sides of this equation by number 4, which I get 2y squared minus 5y minus 3 equals 0. Okay, so I have ended with this nice equation. Now it's very simple to solve this equation. I'm going to use the delta discriminant here in order to find out the roots of this equation. So I'm simply going straight to the solutions. So I get first solution, first solution y equals minus half, and the second solution I get y2 equals 3. Okay, now I'm going through each solution. So I'm going to start with the first solution. I'm simply going to take this value of y, insert it into the first equation to see what's given us. So I have x squared plus z squared equals y squared, which is minus half square minus number 4. This one is given as 1 over 4 minus number 4. This one is given as minus 16 plus 1, which is minus 15 over 4. But the problem, this one is negative, but the right hand side of the left hand side is positive, which is impossible, which means we have no solution at solution for y1 equals minus 1 over 2. Okay, so this one, it's impossible, it's not solution. Now the only solution that I will have, this one. Now I'm going through this one. Now I'm simply going to do the same thing by plugging this one into the first equation and second equation, and to find y, to find x and z. So I get here x plus y, which is plus 3, minus z equals 4. Second one I get x squared minus y squared, which is minus 9, plus z squared equals minus 4. So I will have a reduced equation, which is x minus z equals 4 minus 3, which is 1. The second one I get x squared plus z squared equals minus 4 plus 9, which is 5. Okay, so I'm simply going to replace one of these equations into the other to find out the solution. Okay, I will have z equals x minus 1. Taking this value, insert it into this one, I get x squared plus x minus 1 quinary square equals 5. So I'm going to solve for x now. So I get here simply, I get x squared plus x squared minus 2 times x plus number 1 minus 5 equals 0 by taking this 5 to the left. Now simply I have 2x squared here minus 2x minus 4 equals 0. Okay, so I'm simply going to divide both sides of this equation by number 2. So I will have x squared minus x minus 2 equals 0. Okay, so I have ended with this expression. Now I'm simply going to find the solution for this one. So I get here x equals minus 1, which minus 1, which is 1, plus or minus square root of delta. Square root of delta is 1 square minus 4 times multiplied by minus 2. I get here, this one is giving us 9, square root of 9, which is 3. It's here 1 plus or minus 3 over 2. Okay, I'm going to split that solution into two solutions. I get x1 equals 1 plus 3, which is 4 over 2, which is 2. The second solution I get here 1 minus 2, 1 minus 3, which is minus 2 over 2, which is minus 1. Okay, now I'm going through each of the solution. Now remember, we are using the same value of y2 equals 3. Okay, so I'm simply going to replace everything into, I'm going to plug everything into the first equation to find z. So I'm saying z equals, by taking minus z to the right, I get here x plus y minus number 4. X will be replaced with number 2. And y2 will be replaced with number 3 plus 3 minus 4. This one is clearly giving us 5 minus 4, 2 plus 3, which is 5, 5 minus 4, which is 1. Okay, here is the first pair of the solution. X1 equals 2 with Y2 equals 3 with Z1 equals 1. Okay, let's find the other one. The other one is I'm simply have Z2 here, which equals X2 plus Y2 minus 4. X2 will be replaced with minus 1. Y2 will be replaced with the same value, which is 3 minus number 4. This one is giving us minus 1 minus 4, which is minus 5, minus 5 plus 3, which is minus 2. Here is the second pair of the solution. X2 equals minus 1, Y2 equals 3, Z2 equals minus 2. Okay, here is only two solutions that I found for this equation. So I have ended this video. Thank you. Bye.